Hey guys, my name is Arjun and I'll be doing question number 19 from section 6.3. The question states, consider the linear transformation t going from R2 to M2 by 3 defined by tx comma y is equal to the matrix C negative x negative y, 0, 2x plus 2y, 0, 3x plus 3y, and negative 9x minus 9y. And the question is asking us to find the kernel, the range, as well as both of their dimensions. In order to find the kernel, I wrote in set notation x comma y is an element of R2, which is the vector space we're starting with, such that the defined matrix C is equal to the 0 vector in the vector space we're going to, which in our case is a 2 by 3 matrix C. And then by setting all the non-zero components in our defined matrix C equal to 0 and solving for y, I got y is equal to negative x in all four cases. And I wrote the kernel of t is equal to the set x comma negative x, since I replaced the y with the negative x, such that x is an element of the real numbers. And then I factored out an x and got that the kernel of t is just the span of the set 1 comma negative 1, and that the dimension of the kernel then is just equal to 1. And the range of t is defined as the set tx comma y, such that both x and y are elements of the real numbers. And by replacing tx comma y with the defined matrix C, such that x and y is an element of the real numbers, I separated the defined matrix C into just x's on the left side and just y's on the right side. And I factored out the x and the y, and since they're both being multiplied by the same matrix C, I wrote the range of t is equal to x plus y times the matrix C negative 1, 0, 2, 0, 3, negative 9, such that x and y is an element of the real numbers. So then we know that the range of t is equal to just the span of that 2 by 3 matrix C, negative 1, 0, 2, 0, 3, negative 9. And therefore giving us the dimension of the range is just also equal to 1. And from the generalized rank nullity theorem, the dimension of the range and the dimension of the kernel is supposed to equal the dimension of the V, or the vector space we're beginning with, which is R2. So the dimension of the range plus the dimension of the kernel should equal 2, and in this case it does.